Volvo breaks the internet announcing its latest truck, and LG announces a new use for hydrogen in South Korea. All of this on today's Hydrogen Podcast.
So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
In a press release on June 20th, Volvo Trucks showcases new zero-emissions truck. Imagine a truck that only emits water vapor, produces its own electricity on board, and has a range of up to 1,000 kilometers. It's possible with fuel cells powered by hydrogen, and Volvo Trucks has started to test vehicles using this technology. To decarbonize transport, Volvo Trucks already today offers battery electric trucks and trucks that run on renewable fuels such as biogas. But in the second half of this decade, a third CO2 neutral option will be added to its product portfolio: fuel cell trucks powered by hydrogen. In a quote from Roger Alm, president of Volvo Trucks, "We have been developing this technology for some years now, and it feels great to see the first truck successfully running on the test track. The combination of battery electric and fuel cell electric will enable our customers to completely eliminate CO2 exhaust emissions from their trucks, no matter transport assignments. The fuel cell electric trucks will have an operational range comparable to many diesel trucks, or roughly up to 1,000 kilometers, and a refueling time of less than 15 minutes. The total weight can be around 65 tons or even higher, and the two fuel cells have the capacity to generate 300 kilowatts of electricity on board. Customer pilots will start in a few years from now, and commercialization is planned for the latter part of this decade." Again, according to Roger Alm, hydrogen-powered fuel cell electric trucks will be especially suitable for long distances and heavy energy-demanding assignments. They could also be an option in countries where battery charging possibilities are limited. Now, in this press release, Volvo lists 3 key points. The first is that these trucks generate their own electricity. They say a fuel cell generates its own electricity from the hydrogen on board instead of being charged from an external source. The only byproduct emitted is water vapor. Now, to those of us listening on the hydrogen end of this, we've known this for some time, but the listening base to Volvo may not know about this just yet. And so that makes this first bullet point a very crucial part of this press release. The second point they make is that the fuel cells will be delivered by Cellcentric. The fuel cells will be supplied by Cellcentric, which is the joint venture between the Volvo Group and Daimler Truck AG. Cellcentric will build one of Europe's largest series production facilities for fuel cells, especially developed for heavy vehicles. Now this is huge news. The fact that 2 of the largest heavy trucking groups in Europe have done a joint venture to create fuel cells is massive news. And lastly, they point out that more green hydrogen is needed. So fuel cell technology is still in an early phase of development, and there are many benefits with the new technology, but also some challenges ahead. One of them is large-scale supply of green hydrogen. Another is the fact that refueling infrastructure for heavy vehicles is yet to be developed. And lastly, in a quote by Roger Alm again, "We expect the supply of green hydrogen to increase significantly during the next couple of years, since many industries will depend on it to reduce CO2. However, we cannot wait to decarbonize transport. We're already running late." So, he says his clear message to all transport companies is to start the journey today with battery electric, biogas, and other options available. The fuel cell trucks will then be an important complement for longer and heavier transports a few years from now. Now, I understand why this point was made, and one of the talking points that I'm pushing right now is to start removing the colors from these talks. And so really what Roger Alm should be saying is that we don't necessarily need green hydrogen, we need low or no carbon hydrogen, and even more so, negative carbon hydrogen. But that being said, these 2 Leviathans, Volvo and Daimler Truck, uniting to move the hydrogen heavy trucking forward, Very little can stand in the way of them pushing development and even infrastructure. Next, in a press release from LG on June 20th, LG Chem to produce and run NCC plant on hydrogen. And it was on June 20th that they announced their plan to produce hydrogen as a key component of their long-term 2050 net zero corporate sustainability goal. Aligned with this goal, South Korea's largest chemical company said it would establish a plant in Daesan, Korea, with a production capacity to produce 50,000 tons of hydrogen annually by the second part of 2024. This plant will be the first LG Chem site to produce pure hydrogen, apart from those earned as off-gases. According to the head of petrochemical business at LG Chem, the establishment of our hydrogen plant and CO2 circulation system is an effort to create a sustainable future for our petrochemical business by achieving carbon neutrality. Hydrogen will allow us to convert our petrochemical pyrolysis to a more sustainable low-carbon process. The new plant employs technology which converts methane to hydrogen by creating a chemical reaction under high-pressure steam. Hydrogen will be made from methane off-gases generated by the Naphtha Cracking Center in the process of producing feedstocks. The hydrogen will then be high temperature to be used as fuel again. Construction of LG Chem's hydrogen plant is expected to commence in the first half of 2023 and scheduled for completion by the second quarter of 2024. Once fully operational, LG Chem expects the plant to reduce carbon emissions by 140,000 tons annually, or equivalent to 1 million newly planted trees, by replacing methane used in the NCC process with high-purity hydrogen, which doesn't create any carbon dioxide during combustion. The petrochemical industry produces base chemicals such as ethylene, propylene, and butadiene, which are made by breaking down naphtha at high temperatures. Methane is commonly used as a heat source for the NCC process, which generates a large amount of carbon emissions. The plant is a key component of LG Chem's strategy to increase its use of renewable energy, such as hydrogen, in the NCC process by up to 70% by 2025. As well as to the company's plan to actively utilize hydrogen in the production of renewable biofeedstocks, such as hydro-treated vegetable oils. The construction of additional hydrogen plants will be considered in the future based on carbon reduction efficacy. And through these efforts, LG Chem is confident it can create a value chain in which CO2 generated from hydrogen production process is repurposed as a useful resource. More than 90% of hydrogen in the Korean market is produced using the steam methane reforming process that extracts hydrogen from methane. The resulting CO2 off-gas has been viewed as an unwanted byproduct. The solution involves LG Chem joining hands with Taekyung Chemical, the largest carbonic acid gas producer in Korea, using high-purity CO2 as raw material. Under the terms of the recently signed Memorandum of Understanding, LG Chem will capture the CO2 generated from producing hydrogen utilizing a blue hydrogen production method for supply to Taekyung Chemical, creating a clean, circular ecosystem in the process. Both LG Chem and Taekyung Chemical have pledged to work closely together to establish a seamless CO2 supply system and various ways to utilize it in the long term. Okay, so this is a very interesting press release. One, because I didn't know LG had a chemical manufacturing plant, and two, because I'm wondering how many naphtha crackers in the US can actually use this hydrogen generating process. And now, knowing that LG is doing this kind of work, I wonder if there are any other South Korean tech companies that could be looking to do the same thing. And really, I'm thinking about Samsung. Now, I know for a fact that Samsung is very interested in hydrogen, and they do have a chemical division. And because of that, I would not be surprised if in the near future we see Samsung announcing something very similar to this. Now, here in the US, they're setting up a major distribution hub and manufacturing facility outside of Austin, Texas. Now, I doubt they're going to be doing this kind of work at this facility. But with South Korea being so keen and focused on utilizing hydrogen, I wouldn't be surprised if they're taking notes from LG on how they can leverage hydrogen at this facility. And lastly, I'd like to read a snippet from an email I received from one of our listeners, who brings up a very good question. He writes, in response to your podcast about Elon Musk and hydrogen, his comment is that the main debate about whether hydrogen can fit in for many use cases comes down to the relative pricing of hydrogen or ammonia versus the alternative, i.e. battery. It seems the conflict is expressed in qualitative terms, i.e. yes-no hydrogen for application X is based on an undisclosed learning curve estimate. What would clarify the debate, he believes, is if there was a forecast on price of kilowatt hours for hydrogen versus electricity. Then that's adjusted for application-specific use cases, e.g. weight, safety, transport, accessibility, and duration. Now, he's not off base at all in wanting to have something that drives down the cost of hydrogen in some kind of comparable way to electricity, to kilowatt hours, to batteries, to natural gas, and to any other type of energy or power. And that's not an easy task. Because, for instance, if you want to compare a battery, a lithium-ion battery, to hydrogen, well, all of the cost is really already sunk into the battery. So the only real charge that you'll face with the battery is the price of pumping electricity into that battery, which is very minimal. That versus the cost of filling up compressed hydrogen into a vehicle. And because those two are so far apart, it's difficult to make an economic comparison between the two technologies. And the same is also true for hydrogen and gasoline, because comparing the energy density of gasoline to hydrogen, it's easy to use volume as your unit of measure, i.e. gallons or liters. But hydrogen is always measured now by unit mass, which is usually kilograms. And so because of those factors, it can be difficult to measure hydrogen economically and compare it to batteries or traditional fuels. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, whatever it is. That would be a tremendous help to the show. And as always, if you have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. And as always, take care, stay safe. I'll talk to you later.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.